there, this is Professor Eckhouse, and I'm going to talk to you today about factoring trinomials. This video is going to be in two parts, so this is part A, and I will talk about greatest common factor and factoring a trinomial with a leading coefficient of 1, and you'll know what that means soon. All right, so what is a factor? And the best way to explain this that I have heard is it is a building block of multiplication. Building block of multiplication. Okay, so all the factors multiply together to make the thing that multiplies. They all multiply together to make, right? They build up to make the product. Okay, so the next thing we're gonna do is you just need to remember how to do the prime factorization of a number. If you've never learned this before, you might want to get some help on it because it is kind of assumed that this is a review. So the way I do prime factorization, there's the ladder method and there's the tree method. I use the tree method. It's just what I've always done. So think of two numbers that multiply to make 72. Any two numbers will do because you're going to keep factoring them until they go down to primes. So you need to know your primes. The first few primes are like 2, 3, 5, 7, 11, 13. You won't see any more than that probably in this class. All right, so 72 factors to 8 times 9. 8 is not in that list. It's not prime because it is made up of two other numbers at least, maybe more. 2 times 4 is what I'm getting. And then 4 still factors down to 2 times 2. Okay, so these are all factors, which means they multiply to give the product. All right, we still need to do 9. 9 is 3 times 3. Okay, so those are primes. So notice I have circled all the primes. So now we're going to take this number and we're going to write it in factored form, 2 times 2 times 2 times 3 times 3. Or you can say this is 2 cubed times 3 squared. Now, if you are in doubt, use your calculator and just multiply it all together. 2 times 2 times 2 times 3 times 3 should equal 72. All right, so what is a greatest common factor? All right, the greatest common factor is the largest number that divides evenly is the key, divides evenly into two other numbers, or maybe 3 or 4. And it is the largest. So in other words, so I'll put this in other words. The largest factor they have in common, which is why we call it the greatest common factor. Largest, greatest, means the same thing. Okay, so find the GCF, the greatest common factor, of 24 and 72. All right, so 24 is, let's see, what did I start with? I started with 4 and 6. You can do 2 and 12 or 8 and 3. It doesn't matter because after you break it all down, you're going to have the same things in the end. You're going to have 2 times 2 times 2 times 3. And I challenge you to try 8 and 3 or 2 and 12 and see that you get the exact same numbers. So, and we already did 72. It's right up above. So here's how I'm going to do it. I'm going to list these as 24 is the greatest, the factors are 2 times 2 times 2 times 3. And then 72 is 2 times 2 times 2 times 3 times 3. So to find the greatest common factor, what you do is you break it down into primes like this. And there are other methods, but I'm showing you the prime factorization methods because it's going to work for what we're getting ready to do today. All right, so you're going to say, all right, these two match up, these two match up, these two, and these two are the ones that you have in common. Okay, so now you're going to say that the GCF is the 2 times the 2 times the 2 times the 3, which is 2 times 2 times 2 is 8 times 3 is 24. So the greatest common factor of 24 and 72 is 24. And 24 does go into 72 if you have figured that out already. But that's the method. All right, so now the reason we did that is because we can use the exact same method whether we have variables or not. If it's all variables or partly variables and partly numbers, we can use it for all of these. So it's the same technique every time. All right, so the GCF, the greatest common factor of x squared and x to the fifth. All right, so let's do x squared. X squared is x times x. X to the fifth is x times x times x times x times x. All right, which ones do they have in common? This one and this one. So the greatest common factor of this, the greatest common factor is the x times the x, the ones that are highlighted, the ones they have in common, and that is x squared. So notice it is the one with the least, and that will be the case every time. I'll show you the long way today. After today, I will probably jump to just saying it's the least of the two exponents. All right, so let's look at the GCF of 15b cubed and 25b to the fourth. All right, so 15b cubed. So what we're going to do is we're going to do the number. So 15 factors down to be 3 times 5. I picked an easy one, 3 times 5, okay? That's all of it. And then we've got b times b times b. All right, and then we've got 25b to the fourth. And that is going to be 5 times 5 times b times b times b times b. All right, so let's highlight everything they have in common. So they have this 5 in common, and they have a b, another b, and another b, so 3 b's. All right, so that means that the greatest common factor is going to be the 5, and then a b, and a b. In other words, 5b cubed. Okay, so that is the greatest common factor, just like we found above, but this time with a number. All right, so you give example 5 a try. Pause the video and see if you can do that one without any help. All right, so we're going to do 72c to the fourth d squared. All right, so 72, we've already done 72. It's up above, so I'll just use what we found before. 2 times 2 times 2 times 3 times 3. And then we've got 4 c's, 1, 2, 3, 4, and 2 d's. Now, if you've already figured out how to do this without having to write down all the c's and d's and x's and y's and stuff, go for it. It's fine. All right, so then we've got 27c cubed times d. 27 is 3 cubed, so it's 3 times 3 times 3. And then we've got c, 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 and a d. Those are all multiplied together, don't forget. So all multiplied. All right, so let's go look for common factors. So we've got a 3 here and a 3 here, another 3 here and a 3 here. All right, now we've got 3 c's and 1 d. All right, so the greatest common factor is a 3 times a 3, and then 3 c's and 1 d. So that's 9 c cubed d. All right, so if you haven't noticed, if you go look at the c's, c to the fourth and c to the third, you go with the one that's the least. This one's a d to the 1, you would go to the one that's the least, and that's what we got over here. Okay. So next we're going to look at factoring polynomials. The first step in factoring a polynomial is to factor out the greatest common factor. So if you can do that first. Remember, factoring just means we're using the distributive property backwards, right? So distributing is multiplying. Factoring is basically dividing. We're just dividing things back out. We're pulling things out. The trinomials we are working with are usually quadratics in standard form. So the thing you need to recognize here is this form here, that the letter we use for the coefficient in front of x squared is a, in front of x is b, and the constant we use c. And that's what we always do. And we're going to use that a lot in the next couple of videos here. Okay, so remember when we distribute, we multiply the x times the y to get xy, and then we multiply the x times the z to get xz. So if we took this backwards, we would go look for something that they had in common, and we would pull that out and bring it out front. Okay, so we're just moving backwards. All right, so let's look at some examples. Let's factor the, and this we're just factoring the greatest common factor, because that's all you can do here. So we're going to do this the long way, because I want to show you how to do this using prime factorization. So 12 is 3 times 4, and 4 is 2 times 2. Okay, so 12 is 2 times 2 times 3. Okay, so those are the numbers we're left with when we factor it down. And then x to the 4th, x times x times x times x. All right, so now we've got, for the other one, we've got 15, which is 3 times 5. So 3 times 5. And then x squared is x times x. All right, so now what we're going to do is we are going to go look for all the common factors. So I don't have them written one above the other, but you could if you wanted to. So in the purple one, we've got a 3. In the pink one, we've got a 3. In the purple one, we've got 2 x's. In the pink one, we've got 2 x's. So those are the things that are in common. So the greatest common factor is going to be, let's come over here. The greatest common factor is going to be 3x squared. All right, so that is what we're going to pull out front. We're going to pull out the 3x squared. All right, so we've got 3x squared times. Now, what is left for both of these numbers? Now, here's the nice thing about doing it this way. I can go back over here and say, well, I've got a 2 left, another 2 left, and 2 x's left. That means what I have left out of 12x to the 4th is 2 times 2, which is 4, and x times x, which is x squared. That was these 2's and those 2 x's. So that's a nice way, a nice thing that comes of this method until you get good at it and can do it more in your head. So what's left out of 15x squared after we pull 3x squared out? What's left is that 5 right there. So we would say plus 5. All right, if you are unsure, multiply it back out. So distribute, take 3x squared times 4x squared, and you're going to get 12x to the 4th. Then multiply the 3x squared times the 5, and I get 15x squared. So this is my check. I'm multiplying it back out. Did I get my original? Yes, I did. So we're good. It checked. So our answer is this right here. All right, let's move on. You try this little challenge. See what you can do with it. And then come back and watch. Okay, so we've got 6, which is 2 times 3. So our first number is, there's going to be 3 here, so I'm going to have to write small. We've got 2 times 3, and then x to the 4th, x times x times x times x, and y cubed. All right, the next one, I've got 27, which is 3 times 9, which is 3 times 3. So we've got 3 times 3 times 3 times x times x times y times y. Okay, so that's the 27x squared y squared. And the last one is 3 times 10, and 10 is 2 times 5. Now I'm going to put the numbers in order, so I get 2 times 3 times 5. Double check, 2 times 3 is 6 times 5 is 30. Yep. Times x times y. All right, so let's go look for the common factor among all of these. So I see, all I see is a 3. So 3, a 3, and a 3. That's the only thing that all of them have in common. Okay, so what's my GCF here? So I'm going to just look for my GCF first. And I'm going to say that it is 3. And then how many x's can I get maximum? Well, this one only has 1. So that means I can only pull out 1. Again, going with the lowest degree, right? Going with the lowest degree, so you can do it that way also. And then same with the y. They only have 1 y here, so I'm going to say that's the one I have in common. Okay, so that's the greatest common factor. All right, so Coming down here, we're going to factor that out. So 3xy is factored out of this big long thing. So what is left? Well, what's left is the 2 times x times x times x times y times y. Okay, so that's the first one. So we get 2x cubed y squared. All right, the next one, in fact, I think I'm going to write that in the purple that I had so you can keep track of which one it is. So I get 2x cubed y squared. That's the purple one. All right, now there's a plus right here, so I need to use a plus here. Okay, so now I've got what's left. So the next one, 27x squared y squared. We've got 3 and a 3 and an x and a y. That's what's left. Okay, so I'm going to have 3 times 3. Oop, 3 times 3, that's 9. 9. And then I've got x times y. Okay, next one. The last one is the blue one. So what do I have left? I have a 2, a 5, and no variables. So 2 times 5 is 10. All right. So if you don't believe it, check. So go back. I'm not going to take the time to do this, but pause the video. Take this times that, and I'm going to double check from my notes, make sure I've got it all right. And then take this times that, and then take this times that, and see if you get your original right up here. And it should give it to you. And I know it does because I actually checked before I did this video to make sure that I had it right. Okay. All right, so factor a trinomial with a leading coefficient of 1. So always start by factoring out the greatest common factor if there is one. And remember that factoring is just undistributing. So let's start by just multiplying this just to see, just so we can talk about undoing it. So this is distributing. Next, we're going to take it and we're going to factor it back out. And I want you to see that we're just doing the opposite. So we're going to, I use FOIL. So we're going to say x times x. So that's x squared. And then I'm going to go to my outside term, minus 2x. Then I go to my inside term, plus 5x. And then I go to my last terms, and I say minus 10. 5 times negative 2. Okay, so I want you to notice that this is split up into 2 when we do it like this. And that is something we're going to keep track of as we go through all of this, because that's how we're going to factor. All right, so we're going to undistribute. We're going to end up with 2 parts. So notice that we get x squared minus 2x plus 5x is 3x minus 10. Okay, so this is the difficulty that we have, especially in the next video. But I want you to see what we end up doing here. So now we're going to factor this exact same one without looking at what we just came from. All right, so first thing you got to do is you've got to look for a, b, and c. So remember, this is ax squared plus bx plus c. All right, so in this case, what is a? Well, a is 1 in front of the x squared. What is b? It's in front of the x, that is 3. And what is c? Pause the video and think about it. C is going to be negative 10. All right, so next what you want to do is you want to find your factors of AC, and then we need to find bright B here, and we're going to use this little table to, sorry, I'm rearranging here so I can write easier. So we're going to have the factors of AC. So what is AC? Well, AC is negative 10, and the sum of the factors is going to be B. So your sum of your factors, sum of the factors in orange right there, that's what I'm talking about, sum of the factors. Okay, so AC, what are the factors of negative 10? All right, so let's look at this. The factors of negative 10 are going to be negative 1 and 10, or 1 and negative 10. So what is the sum of those two? Because that's what's going to form the middle term. The sum is going to form the middle term. Okay, so we get negative 1 plus 10 is 9. 1 plus negative 10 is negative 9. Those are not 3. We're trying to get 3. Okay, that's the middle term right here. We're trying to make that equal 3. So what's something else that multiplies to make negative 10? Well, we can do 2, negative 2, how about, and 5. Or we can do 2 and negative 5. Well, what's the sum of negative 2 and 5? That's 3. Aha, we found it. Let's just continue to make it complete. 2 and negative 5 is negative 3. But we found the one. The one we were looking for is this one. All right, so here's what we're going to do next. We're going to use this information right here, and we're going to say, well, we get then that x minus 2 and x plus 5, so the minus 2 goes here, the 5 is there, is going to be the factor of x squared plus 3x minus 10. Not sure you believe it? Well, double check. So here we go. Let's double check. X times x is x squared. Outside terms 5x. Inside term minus 2x. Last term minus 10. Sorry, I forgot my x. So I've got x squared plus 3x minus 10. Is that what we were factoring right up here? Yes, it is. All right, so that's the method. All right, see if you can repeat that and do this one. Pause the video and give it a try. Okay, so first you want to find A, B, and C. So A is 1, B is 1, C is negative 20. So we want the factors of A, C, which is negative 20. The sum of the factors is going to have to be 1, because that middle term, the 2 add up to be 1x. All right, so factors of negative 20. Negative 1 and 20, 1 and negative 20. The sum of those is definitely not 1, because we get 19 and negative 19. Okay, so those are not, that's not it. Okay. It's kind of dramatic. Why don't I just erase that? All right, so we've got negative 4 and 5, or 4 and negative 5 are going to make 20. All right, so let's sum those. Negative 4 plus 5 is 1. Oh, we found it. Yep, we found it. So we got negative 4 and 5 and 1. That's going to be our factors. So we can stop looking for factors of 20. Once you find it, you can stop. So we get x minus 4 times x plus 5. So let's double check and make sure it actually works. X squared is the first term. Outside term is plus 5x. Inside term is minus 4x. And the last term is minus 20. That becomes x squared plus x minus 20. Is that the one we were given? X squared plus x minus 20? Yes, it is. So we did it. And our answer is this. And our check was this. And it checked. All right, let's try one more. So this is the last one. Why don't you give it a try on your own? All right, so A equals 1, B equals negative 5, and C equals 6. So the factors of A, C, which is 6, is what we're going to list. And the sum of the factors has to be B, so that's negative 5. All right, so factors of 6, 1 and 6, or we could do negative 1 and negative 6. And how do I know I'm going to have to be negatives? Well, my answer needs to be negative. So how am I ever going to get a negative out of two positives? So I'm going to have to deal with negatives here. So the sum of the first one is 7. The sum of the second one is negative 7. That's not it. So what are the other factors of 6? Well, it would be 2 and 3, which we know that's not going to be it because it's not negative. But what about negative 2 and negative 3? Because negative 2 times negative 3 is 6. Well, when you add them, you get negative 5, and we found it. That's what we were looking for. All right, so we get this one is the answer. So our factor is going to be x minus 2 and x minus 3. So let's check. So this is our answer. Probably shouldn't box it until I check, but let's check and see. So let's do first is x squared. Outside is minus 3x. Inside is negative 2x. And last is plus 6. Negative 3 times negative 2. All right, so we get x squared minus 5x plus 6. Is that our original? Yes, it is. So it checks, and we're good. All right, can every trinomial be factored? Can every trinomial be factored? I forgot I did have one more. So let's look at this one. A is, and I don't know how I missed this, but it did not get in my notes here. I'm going to wing it with you. All right, A is 1, B is 3, C is 7. So we've got to find the factors of 1 times 7, and the sum of the factors has to be 3. Factors of 7 are only 1 and 7, or negative 1 and negative 7. Is there any way that those are ever going to equal 3? 7 is prime, so there's nothing else that I could multiply to be 7. So this is not factorable. You would have to use other methods, and there are other methods. Okay? So before you try the next portion here, it would be a good idea to watch this video if you are in my class and have this OneNote. And it's also listed in our Lumen page. All right, this will continue on in the second part.